Welcome everybody. I hope you enjoy this break and you had the opportunity to grab a coffee and just to engage with other participants on the networking and the hallway. Now I have the pleasure to introduce you the next keynote, the keynote number 4 from Airbus. It's a keynote based on sustainable space. We have the pleasure of having with us here on the stage Ariane Bouilly, eco-design engineer at Airbus Defence and Space. She will be explaining to us the importance of eco-design on space missions, on the current and the future developing missions. So, hi Ariane, how are you doing?
Hi everyone, good morning. Thanks Pilar for the introduction. And very happy to be with you today. So thank you for the invitation as well. I guess maybe you can go to my presentation and then. Perfect. So yeah, this morning I want to talk to you about eco-design for space and how we do satellites is also as important, like why we do them and for what we do them. So that's really the topic of what I'm going to talk about this morning. So to tell you a bit about myself, so I have a background in environmental engineering. So I studied absolutely nothing related to space. And I was also part of the SGAC family since quite a while. So I started with the SGAC as part of the second European Space Generation Workshop organizing team, and after that, a few other positions. I joined Airbus Defence and Space around 3 years ago, directly as an eco-design engineer, and I'm since then based in Germany, in Munich. And I'm also SME for the Working Group 3, so some of you have already seen me and talked with me yesterday. And of course, we'll be happy to present you the results of this group at the end. During the presentation, I will use Menti, so you can already grab your phone and start with this first question that I would like to ask you. And if you can put your inputs in the Menti, so you have I don't know if you have already used it, but you can log in through your phone via the link that is shown above, so menti.com, and you will be asked for a code, which is the numbers that you see. And if you log in there, then you will be seeing the first questions, and you can type your answer and submit them. What I would like to ask you is, without having maybe thought about it before, what would you say are the environmental impacts of a space mission and of the space industry in general? So what this kind of industry that we are having is impacting, how it's impacting on the environment. So we should see the answers coming in. First, we have combustion and transportation, so mainly linked to fuel consumption. I just give it a few seconds more, so you can submit also many times if you wish. You can give many answers. Debris, we see materials, a lot of one-time use, the shipping of elements, rare metals that are used. So I think it's definitely also showing a bit what I was wanting to demonstrate. There are lots of impacts that are related with this kind of activities. Debris is definitely coming back a lot. I guess it's no surprise because it's also one topic that we hear a lot about. Okay, I leave it 20 seconds more and then I switch slide. Sound pollution is one that we hear a lot for aviation, actually also. Okay, cool. So I'm going to change slide. I don't know if you will still be able to submit, but let's see. So what we see on our side, the most important environmental impact linked to space, it's not the only ones, but ozone depletion is one very specific one also for space, because it's the only man-made activity that is actually crossing the ozone layer, and that's impacting it. Definitely what you also mentioned, resource depletion is a main impact of space. Climate change, which is one that is a main impact of most industrial activities, so nothing specific with that. And then another impact is, of course, the use of the orbital resource. There are many more than that, but it's definitely the main ones. And then I have the second question for you. Which part of the industrial activities you think are causing this impact? So where are these impacts really coming from? When we do the space mission, at which step of the activity is this impact appearing? So testing is definitely one. Hydrazine is a good one as well. Definitely not a very nice chemical. Manufacturing, I see also manufacturing testing. So these all on-ground activities. Some design guidelines, which is true, like the way we plan the satellites and we design them, and also the overall constellation architecture is also something that can have an impact. Ground station, I see here popping up as well, which is definitely true because of also the length of time that they are used to support satellite missions. Absence of regulations, I see. So this one, I guess we will come back to it, which is, yeah, a good one. And yeah, definitely manufacturing, launch are two big ones that are appearing there. Okay, I will switch so that we can also see the other slide. So definitely some of the important causes of environmental impacts that you mentioned are the main ones. So the materials that are used for the spacecraft production and the launcher production, the different fuels consumed, so either for launch or for the satellites, also all the energy that is used during the production processes and manufacturing. All the impact of infrastructures themselves, because most of the time we build infrastructures for the production of one satellite, which is like a one-time infrastructure for one satellite sometimes, which is really impacting also all the traveling that is going on back and forth, and also to the launch pads. And then in terms of space debris, so it happens that there is no deorbiting or that it fails, and this is also one of the cause of impacts. Okay, so then if we go to the next one, this one is, the three next slides are going to be very generic, but to present when we talk about eco-design, what do we have to really think about? So there are three main pillars that we always have to think about in our work. First is the fact that the impacts of any product, satellite for us, but any product is occurring at different stages of the life cycle of the product. So it can happen during the raw material extraction, during the manufacturing of the product, during all the transportation step, during the use phase of the product, which is a really long one for satellites, and also at end of life. And there we don't only talk about the end of life of the satellite itself, but also of all the other models that we use, all the ground stations that are still on Earth that we can do something about. And so all of this is definitely something at stages where the impact is occurring. So the first pillar of eco-design is really to have this life cycle view. Then the second one is really to think during this whole life cycle, there are lots of things that are impacting the environment through the flows of resources that we take in, and of different emissions that we put out. So there are lots of different pollutions, either in the atmosphere or as waste that are produced, and also different, we use lots of resources, be it water, be it materials, be it energy, and all of these flows have impacts. And what kind of impacts do they have is really the third pillar of things. So all of these flows are impacting the environment in various ways. The most known way is definitely climate change, but there are lots of other impacts that we have to think about. And for example, in our industry, it's quite important to think also about resource depletion, because we are quite an intensive industry on this domain. also on toxicity to the environment, all these kind of impacts, and there are many more. So I guess then one good question is, okay, why do we even care? As a satellite industry, it's maybe not the main topic that we have in mind. Yes, it's true, but there are also very good reasons why we should care. The first one is because our industry is the user of some resources and sometimes the main user of these resources. For example, germanium for the solar panels, there is very little industry that is using this element more than us. So we should definitely look, and we can be also an actor pushing towards better use and smarter use of this resource. It's not the only one, but for some resources, we are really one of the main users. Also, it's one of the last industrial fields in Europe to use certain hazardous chemicals that are forbidden for the rest of the sectors and for which we have some authorization because of technical limitation. But still, if we are the last one, it means that potentially there will be no supplier in the next years and things like that. So it's also a really trigger to change. And also, so far we've been also saying, okay, space is a really small sector, so we don't really care about that. But if we think of the whole democratization of this sector and the huge growth of the space industry, then this excuse will not be valid anymore, and we will have really to also take care of this topic as any industry is doing or has to do. And these are just like three of the most factual reasons why we should do it. There are many more that are also linked to what we think we should do as humanity. So do we really want to not care about that, or do we want to care about that and target this problem? But so these are the three main factual reasons. And then, like, okay, that's a fact. We have impacts, but what can we really do about it? And is there ways to act? And how can we just make that better? So this is a question that at Airbus we choose to target through two angles. And as it was also mentioned quite a lot yesterday in the presentations, we can only act on what we can measure, and this is also true for our topic. So definitely being able to assess the environmental impact of the activities and the space industry is a critical point, and we have to be able to do studies to assess this impact. There are various types of analysis that can be done, but one that is quite famous and being used is called life cycle assessment, so LCA. And then the second step is really to, once we have really assessed something, is really to go for the improvement and to try to find better alternatives and put in, like, use the usual specifications that we would have to make the product with, but also integrate some good practices into all that to have, in the end, products that have lower environmental impacts. So if we go a bit more into details, if we of the first box, so what does the environmental impact of a satellite look like? So this is a graph that is a bit showing for each of the steps of the life cycle and each of the parts of the satellite, where are the main causes of the impact. So it's a table that we made coming from different studies that we compiled in this one to just show a bit of a summary of the main hotspots, let's say. And definitely you see that there are lots of different drivers. So for example, in the testing, as we were saying, like the number of tests and the number of test models is definitely a driver of the impact. So if we can also change this test strategy to integrate this environmental topic, is also definitely not a lost cause. If we look at things having impact on resource depletion, it's definitely germanium in solar arrays and also all the different rare metals in electronics, for example. And then in terms of propulsion, it's also definitely, so when we talk about electric propulsion, it's also having a high impact on energy consumption for the production of the xenon. So it's also things that have to be considered when we change of technology for going towards this kind of other type of propulsion. So this is what the results can look like at the scale of the satellite, but it's also interesting to look at the scale of a technology, so much more smaller scale. And there it's when we do this kind of LCA assessment on a specific technology level, there we can really like have a close view on where the impact is coming from. So for example, this was a study done on structural part of a satellite, and there we can compare where is the impact coming from. Is it more coming from the raw material that we use? Is it more coming from all the industrial process that is behind it? And in that case, it was pretty clear that the material, which is in blue at the top, is very little impacting, but all the process steps, which are requiring lots of energy, are the main drivers of the impact. So there, it's surely interesting to have a look. Can we improve that? Can we use cleaner energy, and how we can do that? And this leads us a bit to the next point. So once we have done these studies, how can we improve it, and what are the levers to do that? The good thing is, as you mentioned at the first question, there are lots of sources of impact. So there are lots of things that we can improve on these different sources. And for example, if we want talking about decreasing the raw material impact there, we can also even make the link to the previous keynote about AI. So there are currently research also. How can we use AI to find alternative materials or research alternative materials that would be able to replace some of the hazardous chemicals that we are using, for example, and things like that. In terms of production, it's really looking into all the waste that are produced, all the energy that is consumed. But end of life, I mentioned it already, it's also possible to look at all the ground support equipment that we are using. Can it be dealt with? Can it be reused? Can it be changed? All these questions are things that can improve, in the end, the environmental impact of the product. Okay, and then this one is a bit provocative maybe, but it's still possible to say, yeah, okay, I don't care, I have other priorities, and I don't think it's a major topic, and yeah, okay, we shouldn't really do anything about that. The only thing is, it would be nice, not for me, but for some people, but it's actually not possible not to care, because there are lots of things really pushing us into that direction. First ones being regulations. So, okay, some of them we have exemptions because the space is specific and we can ask for authorization that other industry wouldn't get. But still, in general, there are more and more regulations coming to us, especially in the frame of the European Green Deal that came out last year. So these are really things pushing us as an industry into the direction of taking more care of environmental impact. And also other standards like the ISO standards. Most industry want to be standardized and certified for these standards, and they are also pushing us to look into these aspects and take better care there. And also, ESA is a main, like, really big driver of these topics, and they have integrated in their contract requirements for the industry to do this kind of life cycle assessment that I mentioned. So now each of the prime and the rest of the supply chain, we have to do this evaluation when we do projects for ESA. And this is also really going into the direction of improvement. And they are, from these studies that are being done, they are also deriving R&D projects to look into better alternatives. And this is also the way that they are pushing the rest of the industry behind them. This is just a brief view of what ESA has been doing so far in terms of projects. So they have studied the launch segment, they have studied the space segment, they have finished to study the ground segment, and there is also a big work done on really putting the whole industry together by sharing as much as they can in terms of methodology through the handbook that they published, which is really giving the rules on how we should do this environmental assessment for space products, and also a database, because as you can imagine, all these studies that we do, they require lots of data, and sharing this data and building upon this data is very important so that we all can do better and go faster on these topics in the future. On the side of Airbus, how we are advancing on this topic, so it's still quite a recent topic, and we had basically the first requirement that we received from ESA in 2018. That's also when the team was created. Since then, we have also done other life cycle assessment studies, first in like full satellite level in design, so which was still rather imprecise, because in design it's still too much changes on the product. We have also in the next years done studies on technological levels, which can be much more precise. At the current time, we have really lots of projects with ESA on LCA. We have also pushing the employees of Airbus to get aware about this topic. So here we managed to do an awareness e-learning, which is one support for the working group 3, but I don't know if some of you have interest, if you can also get it in the rest of the groups. We are also planning to increase the team, which is a really good step for us. And then in the future, it's going to improve even more, because now we are asked to do Scope 3 declaration. So it means publicly declare what the CO2 emission of our products in a year will be. So it's focusing mostly on climate change, but still it's a huge step to do that externally. So it's definitely not a topic that is slowing down. And in terms of how we work and the main pillars that we work in, there is first doing really the operational work, so doing this evaluation, doing improvement projects, but also setting up the whole governance on this topic, because it's really new topics, and we have to make sure that the whole company is really taking up these topics, and also building the whole infrastructure to enable the company to do that. So all the databases that are needed in the background, all the tools for the evaluation, and also in the future to be able to integrate this data in the design tools that all engineers are using, because then it's really the way this data can be integrated into the design choices. And it means also ensuring competence and skills, so making sure that most people can or at least understand these topics and can reuse them in their daily work. And also one very important one is keeping up to speed with the very fast evolving topic. So this is definitely a topic that is always having new subtopics coming to it. So when we talk about circular economy, when we talk about green IT and this kind of thing, so it's always new inputs, and we have to make sure that we don't miss out one, and that we are really also being careful and being proactive on these aspects. So that's it from my side, and I have another small quiz for you on gut feelings and what you think might be the impact. So you can go back to your Menti. And the first question I have for you. Okay, funny. So the first question I have for you is, how much do you think is the relative impact of the launch and the launcher versus the satellite? So is it the launch and the launcher that is around 20 more times more impacting than the satellite? Is it more or less equivalent, or is the satellite at least 20 more times impacting than the launch and launcher? Okay, I see answers coming in. "15 seconds left if some of you haven't answered yet. Okay, so it's relatively like balanced, and yes, the right answer is it's more or less equivalent. So definitely the launch is one time really impacting, but for satellites, what has to be considered also is they have to be used during at least 10 years for most of them, 15 or more. And this is also something that is highly impacting, and also they are integrating lots of high-end electronics with lots of different elements in them. So it's in the end, it's more or less equivalent. And the second question then is, if we focus on the satellite, okay. So if we focus on oh, now it's question 3. Oops, sorry. Oh. Okay, so the question is, if you focus on the satellite, which is the impact you think is really the most important relative to the standard impact of one European person? Is it mostly impacting on climate change? Is it mostly impacting on resource depletion? Is it mostly impacting on ozone depletion, on our water toxicity? Now I'm seeing the time. I think we will have nearly no time for question and answer, which is Pilar, I think you're mute.
Can you hear me?
Yes.
Hi, Ariane. So thank you very much for the presentation and for proposing this format so interactive. It's gonna be it was very innovative compared to what we have done till now in the other keynotes. I think we can do these latest questions, and then I will drop some of the questions of the delegates because they have
good
for you. So yeah, I let you to conclude in this question, and then I will introduce some.
No, but I mean, most people are right, and yes, it's definitely impacting on resource depletion and due to the different materials that are integrated in satellites. Like maybe I can leave the other question live while you ask the question, and then people can answer also at the same time.
Yes, and also you can engage after and discuss on the result of the questions during the networking, also in the hallway, because Ariane, you will stay a little bit longer in the event, right? So one of the question more rated, how is ecodesign actually being implemented in Airbus-led satellite missions? Are ecodesign engineer and processes integrated in major reviews, PDRs, CDRs, QARs, or are there other dedicated reviews for this?
So when we give, so we have some deliverables to give. So yes, at that point, the deliverables, they are in the PDR, CDR. And the thing is, we have quite often dedicated session to go more into the details of them, but they are definitely official deliverable at these steps of the satellite, like normal progress meetings. And so far, it's mostly the evaluations that are in these reviews, but there was also one contract where we had already to think of eco-design options and see how to integrate them in the satellite design.
Okay, thank you very much. So the other question is, what sustainability index do you consider, if they exist, when selecting partners for a specific space mission, not only for manufacturing, any type of company?
So this is still something that is not, so it's not used as a selection criteria, or at least not yet, but it's something that we start to evaluate in our supply chain. And what we have also started to do is, because we have to do this LCA work ourselves, and of course the data of the supplier are important to be able to do these studies, then we are also asking them to provide this data, and this is of course evaluated as any requirement that we give to the supplier would be evaluated.
Okay. So we have another very interesting for the future is, what types of regulation do you expect in the future that do not exist today?
So there are at least two ones that are in the making. So they exist somehow, but they are not yet there. One is focusing on batteries and like the critical materials that are in batteries. And so it's not clear yet if the space sector will be targeted, but the chances are that yes. And for that, it means that we will have to go for what the regulation is asking is to go for more recycled material integrated in the batteries, which is so far not the case and which is technically not so easy. So this is definitely the kind of regulations that are there. In terms, I don't think there will be so many like completely new regulations, or maybe some on how much impact we are allowed to have. Like, for example, we have some regulation already not targeting us, but already controlling how much electricity consumption can the product in your house have. So I don't know if this is the kind of regulation that might appear as well. But I think definitely they will focus mostly on material and energy in any case, because it's the two easiest ways to push regulation.
To push regulations. Yeah, this joins another of the questions. Of all the data that is gathered with an LCA and the recommendation that results, what drives implementation of this recommendation? How does change become paramount?
So most of the time, these results, they also highlight some inefficiencies in the way we do things. So when we think of materials and energy, which are the main sources of the impact, when we target one point where there is really lots of environmental impact coming from material or from energy, most of the time it's things that are also wasted. So if we use too much energy, it's also a main driver to reduce that, because it's also a direct cost center for the company. And it's the same for material. So if we think of space, it's an industry where the buy-to-fly ratio, so the difference between the material that we need at the beginning and the material that is flying in satellite is super high. So sometimes it can be like, I don't know, 2% that is flying in the end. So it means that there are 914, now I'm talking German, 98% of material that is scrapped some way in the process, and this is super high. So definitely reducing that is also going to reduce cost, which is a big driver. I don't know if it's answering the question, but
I think it is answering, yes. So especially reducing materials on the process to avoid actually the consumption of energy that is engaged during this process. So Ariane, related to this, in the future we are trying to do a smaller platform. So we have a question: how would you implement ecodesign in new space satellite platform, nanosat and picosat, taking into account the volume, mass and power restriction on this platform that is already smaller?
So I guess there the best way is to think also of the eco-design of the parts integrated in these platforms, because if you do better the parts that you integrate, I mean, also if we speak in terms of cuts and all that, if these parts are also optimized, then it means that the overall product at the end is maybe more easily optimized. So it's definitely, I mean, for bigger constellations, the way to go. And also, I mean, there is also a scale reduction. If you produce more of one thing, then the production per item is lower. But then the question is also, if we go to always more satellites being produced, in the end, it's also not so good. And I guess the real question there is, do we really need them, or do we really think we benefit from them? And in that case, yes, we should go for it. But it's also a general question of how much do we want to consume. So
exactly. So linked to the guidelines and restrictions and policy we answered before. Okay. Thank you very much, Ariane. This was very interesting and very engaging. I think we
maybe just so we have another. Yeah, I can. We have another survey that it would be nice if you could answer before the lunch break. I'm showing now on the screen. So this is a survey for all of you to a bit give your opinion about what you think of a company like Airbus as an employer for yourself. And there will be also like a winner for the people that should reply, and you will get a 1-hour coffee chat with the head of space for Airbus DS. So this is definitely something that you should take as an opportunity. And the quiz should be open, I think, until the end of the lunch break today. And the winner will be announced Saturday next week.
Exactly.
So thank you for giving your opinion.
Take the time to read the QR code, but we will send also the code and the link through email to all the attendees. So keep a link to this survey, and we will announce soon the winners. And now we are going to our working group. So I encourage you to go to the hallway, to the main working group sessions, and then you will be distributed to smaller working groups. Thank you very much for hearing us, and thank you very much for Ariane for joining today.
Thank you.